Math is super fun. Slope is rise over run. I be chillin' in the sun.
Hey guys, let's go over 1.65, the discriminant complex roots. Going dark mode. Alright, directions. Do this with me. So let's go ahead and do this example right here. It tells us to examine negative 5x squared plus 10x minus 15 equals 0. Question, is this in standard form? Better question, what is standard form? It's easy as ABC. Have you noticed this pattern about quadratics? You need to find the ABCs. A is negative 5. Remember, this will never have a variable. B is 10. And whatever C is out here, negative 15. Okay, we need to find the discriminant. Remember, that is what's inside of the quadratic formula, b squared minus 4ac. And we're going to compare it to 0. Let's go ahead and do our substitutions. B is 10, A is negative 5, and C is negative 15. So 10 squared is 100. Negative 4 times negative 5 is positive 20. Positive 20 times negative 15 is going to give me negative 300. And then this would become negative 200. Okay, what inequality are we going to put there? This would be less than. Negative 200 is smaller than 100. So if I look back at my notes, which one had less than? Well, that would be two complex roots. Two complex roots. Remember, the big idea here is your graph. Let's kind of graph this one really quickly. A is negative, so this is opening down. In standard form, the C is the y-intercept. So negative 15. I don't know. We're not really spending much time, but I know the graph's going to do something like this. Oops. Okay, well, I shouldn't have erased it, but what's my mistake here? The mistake is the graph should not actually go through the x-axis. That was my mistake in drawing that. Because two real roots basically means that it's not gonna cross right here. Do you see it? Do you see that? Okay. So we just did that one. For questions 30 to 35, go ahead and complete 3 problems, so skip 3 problems, and find the value of the discriminant for each equation, then describe the number and type of roots for the equation. Number 30. Is it in standard form? It is. Let's go ahead and get our A, B's, and C's. There's no number there, so it's a 1. A is 1. B is 8, and C is 13. I have the discriminant. We're going to compare it to 0. Let's go ahead and do our substitutions here. B is 8, A is 1, C is 13. I get 64. Negative 4 times 1 is negative 4. Negative 4 times 13 is 12. Extra 1, so negative 52. And I'm going to get 12. What's my inequality? That means it is greater than. If it is greater, and this number is not a perfect square, then we have two real rational roots. What does that mean? If you actually use the quadratic formula, the numbers that cross right here and right here will be like whole numbers. I'm just making this up, but trying to show you what rational means. It'll be a decimal, but it ends 4.25 and maybe like -1, positive 1.8. Okay, number 31. So is this in standard form? It's set equal to 0. That's good. I'm going to write standard form. And then we can identify that A is 5. Okay, pay attention here. This one is -1. B is -1. And C is -1. I have B squared minus 4AC. And we're comparing that to 0. B is -1. A is 5 and C is -1. 1 -4 times 5 is -20. -20 times -1 is positive 20. So you get 21. What inequality can we do there? That's going to be a greater. And if it's greater, then same thing, and it's not a perfect two real irrational roots. I was wrong in the last one. It should be irrational. Some weird numbers. Okay. So double check. 12 and 2 irrationals, 21, 2 irrationals. Perfect. Okay, 33. Let's go ahead and get our ABCs. A is 1, B is -2, C is -17. B squared minus 4 times A times C. -2 minus 4 times 1 times -17. -4 times 1 is -4. -4 times -17 is going to be a positive 8 extra 2, 68. And it's going to be greater. But the question is this a perfect square? The answer is no. So we're going to have 2 real irrational roots. And let me just show you why. Quickly graph this. X squared minus 2x minus 17. Okay, so here's my graph. If I put my, it tells me the 0, it's at 5.246260687. It's going to keep repeating, right? That's why it's irrational. The numbers keep going on. That's what irrational means. Negative 3.246, blah, 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 blah. It keeps going on forever. Okay? All right. Let's try number 33. All right, pay attention now. Something that's missing. Do you know what's missing? Okay, let's just say you don't know what's missing. So write standard form. Okay, let's try and do color coded. This one has an x squared, so we have that. That is x squared. Okay, do you have one that has just an x in it? Does 49 have an x in it? It does not. So in this case, you write 0x. Why do you write 0x? Because we have to identify the a, b's, and c's. The b value is in front of the x, but in the original equation, x squared plus 49, it does not have one. Okay, let's do the last one. So then my c value is one with no x in it. There's no x's in it. I hope that was helpful for you to see that. And then we could just say, well, a is 1, b is 0, and c is 49. And then we just write down our formula for the discriminant, which is in the inside of the quadratic formula. And we're going to compare it to 0. b is 0, a is 1, and c is 49. 0, negative 4 times 1 is negative 4. Negative 4 times a positive 49 is going to be 6 extra through, negative 150, no. 16, that would be a 9. Negative 196 is my discriminant. And what inequality can we put in there? It is going to be less than. If it's less than, you look back at your chart, you're going to have 2 complex roots. Again, you can graph that really quickly, and you can see, I can just graph it without graphing calculator to show you. The c value is positive 49, so the graph has to go through there. And we know that's 2 complex roots, so it's never going to touch the x-axis. So it's going to look something like this. Does that make sense? The point is, it sounds so really weird, is it crossing that pink line, the x-axis? It's not. It's complex. If it does cross it, then it's called real. Okay, last 2. Where are you? Okay, so we have A, B, C. It's easy as 1, 2, 3. Okay, what's that one? That one's going to be negative 1. There's no number there. It's either 1 or 0. Think about it. And it has to be 1, not 0. Let's write down our discriminant. B squared minus 4ac. All over 2a. And negative 3 is what? Less than. So if you have a discriminant is negative 3, you have 2 complex roots. Remember, you can always graph that. X squared minus x plus 1. And you'll notice, what? Does it ever cross the x-axis? The answer is no. I can keep pinching and you actually see how far away you are. Okay? And number 35. Didn't save my work. Oh yes. That's okay. At least it was recorded. Is that in standard form? Uh-oh. It's not. C is not negative 2. C is not negative 2 because it has to be set equal to 0. So I'm going to add 2 here. 2x squared minus 3x plus 2 equals 0. Now I can identify my a, b's, and c's. A is 2, b is negative 3. Got the Miami colors going on. And then my discriminant. Let's put that in there. B value is negative 3. C value is 2. Negative 4 times 2 is negative 8. Negative 8 times 2 is negative 16. 9 minus 16 is negative 7. That is smaller. Negative 7 is smaller. That means we'll have 2 complex roots. Okay, so that's how we did 1.65. You're going to stop there. So you should save your work and be able to turn it in. We'll see you guys later. Bye.
It started out with graphene and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3. Now you make that point on the x-axis. Wait, was it a positive 3 or a negative 3?